Hello, and welcome to the presentation on electrified drivelines for medium-duty trucks. My name is Bogdan Havrisciuc, and I work for McLaren Engineering in the Electrified Axle Group. Today we're going to look at the energy usage for three different electric driveline architectures for medium-duty trucks and compare how the energy usage is among these three architectures. McLaren Engineering is the product design branch of Linamar Corporation. We have the capability to design, build, validate, and manufacture our engineered products, and we have offices in North America, Germany, and China. McLaren Engineering has a broad experience in engines and driveline systems, and we're leveraging all that expertise and knowledge when designing our electrification drivelines. For medium-duty trucks, in this case represented by a delivery truck, there are basically three types of electrified driveline architectures: the direct drive, the central drive, and the eaxle. For the direct drive system, we have a larger high-torque motor coupled to the prop shaft, coupled to the axle, which sends the torque out to the wheels. For the central drive system, we have a smaller high-speed motor coupled to a one-stage gearbox, coupled to the prop shaft, coupled to the axle, which sends out the torque to the wheels. And for the e-axle, we have the same smaller high-speed motor coupled to the two-stage gearbox, which includes the axle tubes, which send the torque out to the wheels. The vehicle model is a modified version of the BEV model in GT Suite version 2020. The components highlighted here in red are the components that are interchangeable between the different driveline architectures: the motor, the gearbox, the prop shaft, and the axle. All of the other components remain the same for all of the different architectures. This slide shows all of the common vehicle parameters: the vehicle, the driver's settings, the battery state of charge, and the battery controller remains the same for all of the runs for the different drivelines. The exchangeable driveline components are the electric motor, the gearbox, the prop shaft, and the axle. For the e-motor, we have the high-speed motor capable of reaching 9,000 RPM, and the high-torque motor reaches 2150 Newton meters. For the gearboxes, on the central drive, we have a single-stage gearbox, and for the e-axle, we have a two-stage gearbox. The prop shaft and the axle are the same for both the central drive and the direct drive, and these could possibly be carryovers from a traditional driveline system where you have an ICE engine. In summary, if we connect a high torque motor to a prop shaft to an axle, this is the direct drive system with high torque motor number 2. Now I'm naming this one high torque motor number 2 because I'm using two different high torque motors to compare the difference in electrical usage given the same hardware. What will be the difference between the two different motors? So high torque motor number 1 connected to the same hardware, same mechanical system, will be direct drive system with high torque motor number 1. The high speed motor connected to a single stage gearbox connected through the prop shaft to the axle is a central drive system, and the same high-speed motor connected to a two-stage gearbox will be the e-axle with the high-speed motor. You can notice that the overall ratio between the central drive and the e-axle is the same, so that we can compare, given the same high-speed motor and the same ratio, we can compare what the mechanical losses are between these two systems given the same motor and the same vehicle.